All right, friends, so here's what I noticed. For most of us, A went pretty well. We added these together and we got 3x equals 15. And that told us that x is 5. If I know x is 5, I can throw it in either equation, it doesn't matter. 2 times 5 plus y equals 4. Subtract the 10 from both sides, so y is negative 6. So the answer to this, 5, negative 6. And what does this answer mean again? Yeah, Ivy?
The crossing point.
It's the intersection of the two lines. The solution of the system is that intersection. So then I saw people over here on B, they added this up and they're like, 16x plus 12y is 44.
Yeah, that's right.
True, but how many variables do I have?
2.
So then I'm sitting here being like, you know what? I know I can make equivalent equations if I do the same thing to one side and the other. So what is there that looks like we could almost cancel it out? I like to use the word cancel it out. So far we've been adding things together. What looks like it's right there that we could maybe do a little something and get it to cancel? 8x and 8x. Like, how could I get 8x and 8x to be gone? Subtract it, right? So we are going to subtract it, but I'm going to give you a little trick for subtraction here. I like to subtract so I frame it as, how do I get it to cancel? So in my head, my process is, I need one of these 8x's to be negative. Are you guys seeing that?
Yep.
So I choose to, while is subtraction, multiply everything on negative 1. Which would give me negative 8x minus y equals negative 7. Then, this is just a strategy I like to do, like organizational. I put one single line through that so I can still see it, but so I'm not using it. Now look what happens if I add this equivalent equations together. 10y equals 30. So I did subtract the second one. Are you guys seeing that is subtraction?
So you did.
But to subtract, I choose to multiply everything by negative 1 first.
Yeah, negative 1.
Because if you just put a minus out front here, I'm worried you're going to forget to make the y and the 7 negative. You know what I mean?
Yeah.
So it is subtraction. Like on homework or a test, it's going to be like, should you add or subtract? I would say I need to subtract. But the method I use to subtract is by multiplying everything by negative 1. And the word I have in my head at the front is cancel. How do I get something to cancel? Because if I can get x to cancel, I have a y. If I can get y to cancel, I have an x. So I got x to cancel by making my 8x negative. And that leaves me with a y value of 3. Once I know y is 3, here's why I like to keep that original equation. Once I know y is 3, I can put 3 into this equation because these two equations are the same. So 8x plus 3 needs to equal 7, which means 8x equals 4, which means x is 1/2. So the point that these two lines cross is 1/2, 3. What's another way, if I have this 8x plus y equals 7, what's another thing I could do probably pretty easy to use substitution? How could I use substitution here kind of easy? I'd subtract 8x from both sides. So we're not doing this today, but I'm just showing you. Then we'd have a y value we could put in. We could. I don't think it'd be easier, but option, right? Because later in the unit, you're going to have like all the systems, and it's not going to say do this by doing this. You're going to like choose. It's like tools in the tool belt. Something else I want to point out. What form are all these in? All these lines? Standard form. So generally, if everything's in standard form, elimination seems to usually be the easiest way for people to solve the system. What did the other systems yesterday all have? Most of them were either in slope-intercept or solved for x, and x equals or y equals, which makes sense because you can plug in for x, plug in for y. I'm going to run this through these. I'm going to run you through system A, and then you're going to do B and C as a pod, okay? So I got to go to this computer because this is not going to work nice through the iPad. Through system A. Are you guys recognizing that these three systems are the systems that we already looked at? Diego's and then the other two, okay? So I'm going to need some help from somebody to tell me the equations. So the first Diego equation was like 4x minus 3y equals plus 3y equals 10. And then the other one was?
4x plus 5y.
Okay, and then we solved these using Diego's situation. We got 1, 2, correct? So there's the visual. Now, the next thing it asks for is, what was the sum of these two? So when we added it together, what was the resulting equation? Ivy?
0 plus 8y equals 16.
So 8y equals 16, which really means y is 2. What do we notice about this line?
Straight.
And what does it go through? It goes through the solution. You know why? Because that is the y value of the solution.
If you divide
How many different y's are on a graph? How many different places is y equal to 2? No, like in the whole forever. Infinite. But when y is 2, how many answers are there for x in my system? 1. That's why once we get the y value, we can substitute it back in to get that 1 pumped out.
That's what I got.
Yeah. It's kind of cool to see. So when we add them together, it gives us the screen line that goes through the answer. All right? So you're going to try that for the second and third equations. So looking at the 8x one with the two equations out of 8x, then what?
2x plus 11y
11
equals 37.
37, okay. And then I had an 8x
Plus y equals
plus
7.
y equals 7, okay. And did we get the answer 1/2, 3? Awesome. When we subtracted these, or multiplied by -1 and added, same thing, we got 10y equals 30, correct?
Yeah.
So what do you notice? Does our line go through the solution? Yes, because it's the y value of that solution. All right? Once we know the y value of the solution, how do we find the x? We substitute it into either one. Okay? Every time. It works every time. System 1, what method do you think you would use, Josiah? There's substitution or elimination. Which one do you think? Substitution is what we did yesterday. Elimination is what we worked on today. Yeah, I think this one screams elimination. Because if we add them together, we get 5m equals 101.
Oh, yeah.
And we could solve for m then. I'm not going to do it. The ends cancel out. Do you guys see those ends canceling? Okay.
Oh, that's
System 2.
And that's just 101.
Who's got an answer? Which one should we use for system 2, do you think? Hey. I think this one's asking for substitution. Because I could take my y value and stick it right in for that y. Because where they cross, what's true about the y values? They are the same.
And that one's in slope intersection.
But I'm going to show you something kind of crazy. You guys ready? I think you're ready for this. Can I trust you guys with this?
I don't know.
This is something that I didn't do until a few years ago. And I love it. And I told 2 math teachers today, and I watched them smile like happy little children. Watch this. All of them.
Mrs. Packer.
So this is my system, right? I historically would say always substitution. You got a y equals, so you know what the y is, right? Y equals, you put it in for y. Watch this. Because of the hanger diagram, and because we know if we add up the left sides and we add up the right sides, it's still true, guess what I tried? Guys, I'm about to get crazy. So here's what I tried. I multiplied everything by -1. Now, if I'm adding left side, right side, what do you notice is happening to my y's now? They're canceling. It would leave me with 4x equals 2x minus 8. How many variables do I have? 1. Can we solve it? Sure. No, it's a 1 minus 9 on the right side. So, check it out. If 2x is -8, then x is -4, right? Watch this. If I do my substitution, 2x plus 9 equals 1. Subtract 9. 2x is -8. So guess what? X is same answer, guys. I didn't even know you could do this until I took a conceptual approach, saying add left side, it equals add right side, regardless if it leaves me with 1 or 2. Like, remember in the lesson, you guys added that and got something like 10x plus 15y equals 37? That's true, it just doesn't help us. Add left side equals add right side. You can do elimination with the one that looks like substitution.
feel like that's something that.
How crazy. It's like I'm seeing the sixth dimension now, friends.
I feel like that's something that I would find out on accident.
Yeah, it's cool, huh? Now, I'd still say this one is like begging to be substitution. But we can use any method with any of them. Like, we could isolate y in this. It'd be real ugly, but you could. And then substitute it in, but don't. All right? But I want you to have that flexibility. Tools for the tool belt. I mean it. When you get a test, it's not going to say, solve the system by blah, blah, blah. It's just going to say, solve this system, and you have to choose your method. It's going to be much easier to choose your method if you go based on concept, based on when I saw one that looked like this, I did these steps. You know what I mean? Let's get after it.